Welcome to qnawire.
Over here we're given that a small conducting sphere of X with an X charge of 5 electrons is touched with a sphere Y with an X charge of 2 protons. When they are separated, the possible charges of the spheres X and Y respectively will be, and we're going to select the only ones that are going to be possible. So remember that charge is going to be quantized. That means that we can only have integer numbers of electrons or of protons. We're not going to be able to have, for example, 1.5 electrons and 1.5 electrons. So the first one already is going to be incorrect. So let's verify what is going to be the possible charges after we transfer protons and electrons from X to Y. So let's put the initial condition over here. We're going to have 5 electrons, which corresponds to a charge of minus 5 times charge of the electron, which normally is QE, Q electron, and Y is going to have a charge equal to 2 protons, which corresponds to a charge equal to 2 times the charge of the electron. Okay, remember that electrons and protons are going to have the same value. Now, let's see what happens if we transfer electrons from one place to another. Let's say that we transfer one electron from X to Y. We're going to have the equivalent of 4 electrons and 1 proton. So the charges are going to be minus 4 charge of the electron, 1 charge of the electron. Notice that the total charge needs to be conserved, and the total charge over here would be minus 5 plus 2 times the charge of the electron. So this is going to be equal to minus 3 charge of the electron. So all of the combinations that are going to give us minus 3 are going to be the correct ones. So that is going to happen whenever we have only one. If we transfer two electrons, we're going to have 3 electrons, so minus 3 charge of the electron. This guy can be neutral. Next up, we're going to have minus 2, and minus 1. I'm going to omit the charge of the electron just for getting the results directly. Minus 1 and minus 2, and 0 and minus 3. So from all of these combinations, we can already see that on X, we're going to have the possibility to have 3 electrons and the other guy to stay neutral, which is selection C. And we're also going to have the possibility to have 2 electrons and 1 electron on each. So the two possible answers are going to be B and C.